Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzati Syafiqah binti Muhammad Talmizi, matrix numbers B0921100025. Today, me and my fellow friends will present about our structure. In this group, have 4 more members. Let me introduce one by one. The first one is Aida Basira binti Muhammad Talib, matrix numbers B0921104443. Second members Nur Fardini binti Azizi, matrix numbers B0921210135. The third one Nur Shazwana binti Sahid, matrix numbers B0921100450. The last one Nur Batrisha Iwani binti Syamsul Fahrizal, matrix numbers B0921104444. Today, me and my fellow friends will present about our selected structure and our chosen structure. Hi. Okay, so now I will explain about our objective. We have 3 objectives. The first one, to draw details FBD from actual. Second one, to analyze force member from the structure. The third one, form the equation of equilibrium for FBD. So let me tell you a bit information. For our group, we have chose 3 structures. The first structure is clock. The second one, the trolley. The third one is chair. So for each structure, we have for each structure have their own FBD that we have make it, and the chosen structure is the chair. So for the chair, we have make the equation of equilibrium. But for the further information, my fellow friends will give more details, will give more explanation about that. Okay, so for now, I will explain about our chosen structure. Okay, this is our chosen structure, which is a chair. Okay, this is our chair using stainless steel, and then beside the photo of chair, that is our idealized model. Okay, as we can see in the idealized picture, we have the measurement, okay, which is the height of the chair is 0.84 meter, and the force we have 640 Newton, and the distance 0.02 meter, and we have FNA and FNB, and the distance between FNA and FNB is 0.45 meter. Okay, after this, my friends will explain more about the equation.
Hi, Assalamualaikum. My name is Aida Basira binti Muhammad Talib, and my matrix number is B0921104443. I will explain about the calculation. The formula for horizontal component is the sum of fx equal to 0. So let's look at the x-axis. 66 minus ffb equal to 0. Next, for the formula for vertical component is the sum of fy equal to 0. From the y-axis, we can see that f and a plus f and b minus 640 equal to 0. And lastly, for the moment, here we have the f and b, normal force at b and friction at b. So I'm going to use that point as for the moment equation. So there is negative f and a because it's clockwise direction. Negative f and a times by 0.45 plus 640 times 0.02 minus 66 times 0.84 equal to 0. So we solve this equation and we get f and a is equal to negative 94.76 Newton. For the friction force at B, which is f and b, is equal to 66 Newton. And lastly, for the normal force at B, is 640 minus f and a. F and a we already have there. It is negative 94.76 Newton. So 640 minus negative 94.76 Newton, we can get 734.76 Newton. So we already solved the 3 unknown force, which is F and A, F and B, and the friction force. Thank you.
Assalamualaikum and hi everyone. I would like to present the assumption. The material of chair is stainless steel. The weight estimate is 640 Newton. The length of chair is 0.45 meter and the tensile strength still is 17 megapascal. The radius of chair is 0.02 meters, so we calculate the area of chair, which is A equal to pi r square, is equal to, and the answer is 1.2566 times 10 power of negative 3 meters square. The maximum allowable force that have in this structure, so to find the stress is P divided by area, so 640 Newton divided by area, 1.2566 times with 10 power of negative 3, and the answer is 509395.8 Pascal. So the design is safe. And the value of stress and shear stress are the same. Max allowable force, to find the value is F max time with area. So 170 megapascal time with 1.2566 times 10 power of negative 3, and the answer is 213.622 kilonewton. The factor safety is maximum stress divided by yield strength. So the answer is 1.2566 times with 10 power of negative 3. That's all from me. Thank you.
Hi, my name is Nur Batrisha Iwani binti Syamsul Farizal, and my metric number is B0921104444. Next, I'm going to talk about the discussion part. We got 3 discussion that from the assignment. First, we had to investigate the force that reacts to the chair. Second, there is no moment acting on this structure. And lastly, at the end of the chair, 2 forces are acting on the chair, which are horizontal and vertical. Thank you.
My name is Nur Shazwana binti Sahid with matrix number B09211040. So for this assignment, we can conclude that to avoid potential failure of the product, we assume that the factor of safety has to be more than 1. The value will change based on the material used and potential application of the member. Second, the factor of safety also is essentially used to ensure the structure designing does not allow any unexpected failure or present of deformation or defect. When it comes to safety equipment and fall protection, the factor of safety is extremely important. If our structures fail, there is a risk of injury and death as well as a company's financial loss. So that's all from our team. Thank you.